So we have learned how to calculate the heart rate, right? Which was step 1 in reading the ECG. So step 2 is figuring out the rhythm. Now I'm gonna have a more comprehensive discourse on rhythm analysis as this ECG series goes by. It's not, one video is not sufficient for explaining rhythm analysis. Okay, so there's a lot of things to talk about when it comes to rhythm analysis. So for this part of the series, which is introduction to the ECG, I'm just going to speak about sinus rhythm, right? So how do you know that an ECG is in sinus rhythm? Okay, so first we need to gain an appreciation of what is sinus rhythm. So sinus rhythm, right, is a heart rhythm that originates from the sinoatrial node, right? And what it denotes is that the sinoatrial node is the pacemaker for the electrical activity of the heart, which is the normal situation, right? So again, sinus rhythm means that the heart, no, sinus rhythm means that the sinoatrial node in the right atrium is the electrical pacemaker for the heart. And not only that, but also that the person or the patient, it has a normal heart rate. So for example, someone whose pacemaker is the sinus node, but their heart rate is fast, this would be a sinus tachycardia, right? Not normal sinus rhythm. So I suppose persons sometimes use the word sinus rhythm loosely to include sinus bradycardia, sinus rhythm, and sinus tachycardia, but more technically accurate would be to say normal sinus rhythm, also can be shortened to NSR, right? So normal sinus rhythm is between 60 to 100 beats per minute. Okay, so now that we know conceptually what sinus rhythm is, right, that the SA node is controlling the electrical activity of the heart, we need to now know how can we identify that we are in normal sinus rhythm. So this is how you do it. There are 5 components. Raw. So rate, as we have alluded to already, right? The rate should be between 60 to 100. Great. Okay. Regularity. So normal sinus rhythm is a regular rhythm, right? So not only should it be regular, but in a very specific way, right? You should have every QRS should be preceded by a P wave. Alright? So because the sinus node is what is controlling the ventricle, it therefore means that the sinus node depolarizes, thereby depolarizing the atrium, creating a P wave, and thereafter this propagates down to the ventricle, creating a QRS. So for you to be in sinus rhythm, there has to be a P wave before every QRS, right? And because the sinus node, with very few exceptions, fires at a regular rate as pacemaker tissue, right? It results in a regular rhythm. Okay, good. So now A is axis. So what are we talking about? We're saying axis of the P wave. So under normal circumstances, not only is the mean electrical vector of the heart, right, down and to the left, but also the mean electrical vector of the atrium is down and to the left, right? So both the ventricles and the atrium, the atria in combination, have a similar mean electrical axis. Now, what does this mean? Do you need to go about calculating the actual, degrees of the axis of the P wave? No. All you need to know is that there are certain leads that the P wave should be upright in under normal circumstances, right? And if the P wave is inverted in these leads, it suggests that chances are the P wave isn't originating from the normal point, right? So let me draw this again. If the P wave, if the initial impulse is originating from here and it's going this way, and I'm looking, for example, in lead 1, based on our prior discussions, we would expect lead 1 to have a positive P wave, right? But what if the P wave is actually originating here, right? Let's put a P. And so the vectors are going in the opposite direction with a mean electrical vector going that way. Then you're going to have an inverted P wave. Okay, so an inverted P wave suggests that the P waves, or the mean electrical vector, is going in the opposite direction of where it would normally be, right? So what leads classically should I have an upright P wave in? Well, you can remember that by saying 1, 2, 3, 4. Okay, so of all of these leads, 1 and 2 are most commonly quoted, right? Upright P wave in 1 and 2. But I've seen different sources go up, include AVF and lead 3. Okay, so in summary, you should have an upright P wave in leads 1, 2, 3, and AVF. But at least leads 1 and 2 should be upright, right? And that would suggest that the P wave, right, or the impulse is originating from the sinoatrial node and therefore is resulting in a normal electrical vector for the atria, which results in a normal P wave. Okay, so what else? So the rate should be 60 to 100. It should be regular with a P wave preceding every QRS, preceding, right? The axis, so the P wave should be upright in leads 1, 2, 3, and AVF. The next thing is that under normal circumstances, the QRS should be narrow, right? And that is something that perhaps I should have gone through before when I was speaking about the different waves, segments, and intervals. But I think I'll take the opportunity to go through it now. So a narrow QRS is less than or equal to 0.1, right? 0.1 seconds, right? Which is 2.5 small boxes. Okay, now wide is greater than or equal to 0.12 seconds, or 3 small boxes, and prolonged is between the 0.1 and the 0.12. So essentially it's normal if it's less than 0.1, but for different reasons it can be slightly prolonged but not referred to as wide. So for simplification, right, in sinus rhythm it's typically less than 0.12, right? Which is the same as 3 small boxes. That's the QRS width. So if, let's literally draw a QRS. So we're saying the QRS should look something like that, right? Where it takes up, maybe this is about 2 boxes. Okay, that's how your QRS should be looking. If it looks like this, is wide, then it may not be originating, the impulses may not be originating from the sinus node. But there are other possibilities as well. There may just be abnormal conduction through the ventricles, and this is something that we'll speak about in more detail later on. All right, and then, all right, finally, the final component of sinus rhythm would be the width of the PR. Right? So the PR should be between 0.2, or let me do it, I think I'm saying it in the reverse, right? So it should be between 0.12 to 0.2 seconds. So that's 3 small boxes to 5 small boxes. So I'll take the opportunity now to expound, right? So let's go. All right. So there are some nuances about the height of the various waves that I think would be better discussed in later videos. But for now, I would like to highlight that the PR interval, which we mentioned before, is from the beginning of the P wave to the beginning of the QRS complex, and it represents the time taken from the beginning of atrial depolarization to the beginning of ventricular depolarization, right? So that PR, right, as I mentioned, should be between 0.12 to 0.2, which is 3 to 5 small boxes. So if it's shorter than that, that's abnormal, and we'll speak later on about the implications. And if it's longer than that, it's abnormal, and we'll speak about the implications. But basically, if it's too short or too long, it changes what the rhythm likely is. Okay, so to summarize, right, for a rhythm to be sinus rhythm, to be normal sinus rhythm, the rate has to be between 60 to 100. It has to be regular with P waves before every QRS complex. The axis has to be the P wave axis specifically. So the P waves have to be upright in leads 1, 2, 3, and AVF. The QRS has to be narrow in terms of the QRS width, and the PR width has to also be normal between 0.12 to 0.2 seconds, or 3 to 5 no more than 5 small boxes, no less than 3 small boxes. Okay, so let's look at these 3 ECGs to see if they are indeed sinus rhythm or not. Okay, so ECG number 1, we said we need to assess, hold on, we need to assess the rate, okay, the regularity, the axis of the P waves, right, and the width of the QRS and the width of the PR. Okay, so let's do this quickly. So what's the rate? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Times that by 6. Okay, 6 3s 18, 8, 1, and we're looking at, I think, 78, right? So this is 78 beats per minute. Okay, is this thing regular? Well, yes, it is regular. And are there P waves before every QRS? It really does seem that way. So we have that check. P wave axis. So now we're gonna look to see if the P waves are upright in the leads that we mentioned, right? So those would be lead 1, 2, 3, and AVF. So lead 1, we got upright P waves. Lead 2, upright P waves. Lead 3, upright P waves. And lead AVF, upright P waves. So we can conclude that there's a normal P wave axis. All right. So what about the width of the QRS? All right. Well, essentially, right, it's not absolutely 100% true, but for the most part, the QRS should be approximately the same width in all leads, right? So let's just pick a lead and zoom in. I'm gonna pick lead V2, okay? And we're just gonna zoom all the way in and count it up. So 1, 2, no. This is 1. This is 2. Depends on where you stop. It looks like it's almost 3, to be honest. Let's look at this one. About 1. That's 1. 2. Okay, so let's give it 2, right? So in this complex, it's kind of difficult to say where the J point starts, but these complexes are more clear, right? So I'm gonna go ahead and say that the width of these QRS complexes is about 2 small boxes, which is 0.08 seconds, right? Which is normal, so it's not wide. All right, cool. And then the PR. So again, let's just pick a lead that it's fairly easy to analyze the PR. Let's look at AVF, right? And we found a nice one. The P wave starts about here. All right, so the PR in this one is about 3 plus, maybe 3.5 small boxes. So that PR is normal. So even though there are abnormalities on this ECG, which we haven't spoken about, we can conclude that this is a sinus rhythm ECG. So let's do 2 others. Okay, so rate, regularity, axis, QRS width, and PR width, right? So let's go. So this one is regular, right? Both of them were regular. So let us use one of the other methods that we mentioned, right? So 1, 2, 3, 4, and a little bit. This would make 5. So it's between 4 and 5, right? So that means it would be between 75 and 60 beats per minute. It's a little closer to 70. Well, maybe it's almost right in the middle. So let's say it's about, I don't know, 68 beats per minute, right? So that's okay. It's between 60 and 100, right? Then we're going to look at the regularity, right? So I do agree. I do believe that it's regular. And there are indeed P waves before every QRS. So that criteria is satisfied. Then we're going to look at the P wave axis. So we're looking to see if there are upright P waves in 1, 2, 3, and AVF. Lead 1, all right, good. Lead 2, good. Lead 3, they're tiny but they're there. And lead AVF, great. All right, that's satisfied. Then the QRS width, let's zoom in on a lead. I'll zoom in on lead 2. Let's zoom. All right, and from here to here. So it's a little bit less than 2 small boxes, right? So that is sufficient. That's okay as well. And finally, the PR. So let's zoom in again. We can find hopefully a PR that begins on a hard line. If not, that doesn't really matter that much, right? So this is a fairly good one. That looks like it's the best one, right? So the PR is a little over, maybe it's like about 4 or almost 5 small boxes. Okay, so that is satisfied. So again, this is a sinus rhythm ECG. Let's look at the last example. All right, this one is regular again, so let's use the small box technique this time. All right, so you're gonna count from here to here is about 6 plus 5 11 plus 5 16, right, plus about 4 more 20. Right, so 1500 divided by 20, we did one like that already, so we know it's 75. Okay, so that's the rate. Then we're going to do the regularity, so we know it's regular. And are there P waves before every QRS? It would appear so. Awesome. All right, so it's regular. P wave axis. Okay, let's look at leads 1, 2, 3, AVF. Yep, we got that. The width of the QRS. Let's zoom in. Let's pick this lead. About here to about here. I would say it's about 2 small boxes, and that's fine. All right, so that's fine. And the width of the PR. Which lead can we? Let's use lead 2 again. It's from about here to here. If I had to guess, I would say it's about 4, maybe almost 5 small boxes, which is fine. All right, so this is a normal sinus rhythm ECG again. So I hope this video is very helpful and that the concepts are clear. And as always, you can leave comments if there's anything you'd like me to clarify. Thank you.